Hi everyone, the monthly dev episode number 34. We're super excited. This is an episode that we do, of course, every month, and we've been doing this for about 3 years until now. And yes, today we have, as you can see, 3 amazing guests here. So first of all, sound check and hi everyone. Hi all.
Hello.
Hi.
Good morning.
Top of the morning, or whatever time of day it is for you.
Yeah, good morning, good afternoon, good evening, whatever. Nice. So we are close to the end of the year, so we have just 3 more episodes. Yes. And yes, so today the topic is monitoring and performance. I think they are very technical topic, and I think that we will have fun. So yes, that's it. So just before we start, just want to give a huge shout out to daily.dev, who has been doing this for about 3 years. Free event for everyone. Top class speakers, of course, always on top. And yes, we're trying. And as usual, this will be a 1.5 hour length event. We have one presentation, one talk, and then we have 5 minutes Q&A. And of course, at the end, we will also give another shout out to the dev. So that's it. I think we can start. If you're in the chat, just say hi, wave. I know that you are coding on the side, but you can just put a wave in the meanwhile. But yes, thank you. And I think we can start. So now I'll just kick. I'm sorry, Leon and Jessica, and I'll just start with the Paige. I hope it's the right one. Perfect. So see you later, and bye everyone.
Bye.
Nice. So sometimes I remove the wrong person. Nice. So hi Paige, thank you so much for coming. I see you have a very big smile, and this is really big, puts me like in the right mood, we can say.
Yeah.
So
I love talking observability, monitoring, and performance. This is what I love to do.
Nice, absolutely. So before we start, please introduce yourself. You work at Chronosphere, so you can tell us something about you. When you're ready, we can also share the screen, and then I let your talk to start. Thank you.
Perfect. Well, hello, everybody. If we have not met yet, IRL or on the interwebs, I'm Paige Cruz from Chronosphere. I'm a retired site reliability engineer turned developer advocate, and Chronosphere, oh my gosh, I love Chronosphere for so many reasons, primarily because we're built on top of open source observability standards like Prometheus and my personal favorite, OpenTelemetry. And so I'm going to talk today about optimizing observability spend for metrics, because if you haven't checked your observability bill lately, those things are getting pretty sky high. And I want to make sure you've got the tools and understanding that you need to trim that bill without losing the visibility you depend on when you're on call.
Perfect. And Prometheus is one of my favorite monitoring tools. So a good thing is that when I invite these people, I can also watch my own talks. So super excited about this. So Paige, when we want, I think we can we share your screen?
Yeah, should I reshare?
Perfect.
There we go.
So I like this animation, optimizing observability span, metrics. Thank you so much for putting the monthly dev there. And I think you can start. So if you have any questions, just drop them in the chat. So I'll still be there. And see you later. And best of luck, Paige. Bye.
Lovely. All right, everybody, let's get started today. So I wanted to come talk about this topic because understanding the cost of collecting metrics and evaluating the usefulness of those metrics is really the only way that we can scale in a cloud-native world. Because you can't just get away with collecting everything, having all the default metrics that were turned on when you flipped on integrations. Engineers, we've got to make decisions about what we want to collect, drop, aggregate, so we can be able to understand our systems better. So we'll start with a little example. Imagine this. You're a developer looking to better understand your system by instrumenting a metric. Today, you want to track the request rate per URL subpath. Sounds totally great, fine, normal, cut and dry, right? Except a month later, when the observability bill arrives, you see your boss sees a $30,000 overage, and now your boss has to go beg the vendor to lower that fee. Good luck with that. And upon closer look, the metric you created was accidentally misconfigured to be per unique URL, not subpath. And since there are way more individual pages, thus URLs, in your application compared to subpaths like you'd see on the nav bar, about, blog, contact, it's easy in hindsight, once the bills arrive, to see where that $30,000 came from. And this is not a made-up story. This is sadly a real-life tale. And my takeaway is that without vendors providing you clear and timely data about your data, instrumenting for necessary visibility becomes this terrifying high-wire circus act. Because I'm pretty sure after this billing debacle, that poor developer is now likely afraid to instrument anything else or add another metric. And this fear is the opposite of what we want. We don't want people to be fearful when instrumenting, but we want them to be fearless. Because the better telemetry that's available to developers, the smoother our investigations can go. And considering how big of a problem burnout is in our industry, we don't want the lack of observability to be a contributing factor. But we have to face the facts that observability bills are out of control. They're outrageous, they're expensive, especially for cloud-native environments. And metrics, which we're going to talk about today, represent a pretty substantial portion of that bill. And to borrow a term from Cloud FinOps, a spend panic, a lot of executives have or will soon have a spend panic moment. This is when an unusually high spike in the bill takes an organization by surprise and often results in SRE, ops, and developers getting pulled off of whatever projects they're working on so that they can focus on reducing the bill as soon as possible. And in a spend panic, you get asked a lot of questions like, why is the bill so high? What are these metrics even for? Do you really need all of them? And my least favorite, can you reduce the bill by 30% in 2 weeks? But let's back up. Before we start taking a chainsaw to our metrics, let's take a moment to appreciate them. Because metrics are kind of the unsung hero of observability. And I'm guilty of discounting them in favor of my personal favorite type, which are traces. But metrics power our time series charts on dashboards. They let us very quickly visually analyze data, finding trends and anomalies. They're trivial to generate, dependable, and can be derived from other types of telemetry like logs, traces, spans, and events. Most importantly, metrics play a critical role in powering monitors like the one you see here that alert you to issues. Thanks to metrics, we can see there's clearly an issue going on, and whether you get paged at 3 p.m. or 3 a.m., metrics are often your first peek at an issue. But when we're in the spend panic moment, developers are asked to focus on the cost, that is the financial cost of this telemetry. But considering the value this data brings is also important, because it's not as simple as equating expensive metrics with bad or high value or cheap metrics as the best. It really, really depends. And so, since organizations don't have infinite amount of money, we will talk about both the cost and the value of metrics. We'll start with cost. I think it's important to understand the factors that influence the cost of generating, processing, and storing metrics. And I want to share with you not the one way to do it, but all the levers that you have at your disposal to adjust the financial cost of metrics. So you can either prevent a spend panic or quickly respond when one pops up. So the first factor that influences the cost of metrics is, of course, just how many things you're monitoring. That is the number of applications and containers, infrastructure components, how many boxes are on your system diagram. Second factor is the granularity. That is the frequency that the metric is sampled or the granularity of the time bucket. Sometimes we calculate this as data points per second. Our third factor, of course, is the retention window. Simply, how long are you storing these metrics for? And lastly, cardinality. You may have heard of cardinality in terms of high cardinality is bad, but today we're going to talk about why that isn't necessarily the case. But as it is, cardinality is the size of the set of unique maps of attributes and metrics. So we'll double click into each of these. First, while you as an individual don't have power to affect really the overall number of services and infrastructure components in your org, especially if your business is growing, I do think you can use the cost of monitoring to advocate for accelerating timelines to either sunset or deprecate features or services, or totally cull and get rid of dev and test environments that you don't need anymore. Do some napkin math, estimate how much it's costing to keep those, to monitor and keep those things online, and see if that factors into being able to shut it off sooner, less operational overhead for you, win-win. When it comes to granularity, I found an interesting stat from a DevOps Days London talk: observability is too damn expensive. It cited 99.9% of queries on operational metrics do not ever pass 7 days. Yet on average in the industry, we save your metrics at that original granularity anywhere from 2 to 4 weeks, which is 2 to 4 times longer than your devs are actually querying for them. One way we can adjust the cost of this is called downsampling. It's where you take a fine-grained time bucket, like maybe CPU samples every 5 seconds, and aggregate them into maybe 10-second buckets. And even over time, you can age this out. So a month later, you aggregate from that 10 seconds to 30-second buckets. And after 6 months, maybe all the way to 1-minute buckets. But you're storing less data points overall. And so that brings the cost down. One thing to note when it comes to granularity is that there are times it's valuable to keep the data at its best fidelity that you can. When I was talking to Stephen Townsend, expert in performance engineering, he was lamenting the fact that downsampling made it really challenging for him to do historical comparisons when it came to load testing for certain peak seasonality for the businesses he worked for. So when it comes to downsampling and configuring that, it's worth taking a tour around your organization and talking to folks who use this data in ways that you may not recognize in the moment. Then we've got, of course, retention window, how long you're keeping the metrics. This one, again, is a big lever to pull, but it is worth exploring the usage of your metric data for your system and figuring out what the usage patterns are for your organization. And finally, we do get to cardinality, which is best explained, I think, with pictures. So if we suppose that we've got a stateless microservice configured to autoscale, it's containerized, probably running in Kubernetes, and it is emitting metrics about its behavior. If we were running 100 containers, reporting on total requests across 5 separate endpoints, 4 possible operations, 5 potential status codes, if we multiply 10 by 5 by 4 by 5, that is 10,000 unique time series to track. But do you actually look at these metrics on a per instance basis, especially if we're talking about, say, request rate or latency? We typically care about request latency at the overall service health, not at an individual single replaceable container. So if we're not interested in looking at a per instance basis for this metric, we can drop that label and create an aggregation rule to roll it up before we store it. What does this result in? Reducing the cardinality massively. So instead of 10,000 time series, we drop all the way down to 100. It's a 99% reduction in cardinality, which will save us some big money. But again, high cardinality in and of itself isn't bad and isn't to be eliminated at all costs. Let's look at an example where a potentially high cardinality label could be very helpful for developers. So what if we want to add a dimension that identifies the customer that is being served from this service? If we have, say, 300 customers, that's going to significantly increase our cardinality and would still be massively useful to our developers and customer success who's working on troubleshooting and figuring out tickets. But if we've got 300 customers, when we do the cardinality math, that adds up to 3 million unique time series, which is a lot to generate, store, and pay for. So what can we do? Well, we could potentially limit to a smaller cohort, maybe the top 10 biggest clients that you serve. And what would the impact to cardinality be going from 300 or 300 plus, considering your business hopefully is growing and you'll be adding more customers, that sort of unbounded runaway dimension? What if we drop down to just our top 10 customers? Doing the cardinality math, that lands us with 1,100 unique time series and still brings us great visibility into those top 10 customers. So we've gone from 3 million to just 1,100 unique time series. That's a 99.96 reduction in cardinality with enhanced visibility. So that's one example of how you can manipulate cardinality to spend it where it counts. So that's a bit about the cost. We're going to shift to talking about the value that a metric brings. And a few weeks ago, reading through all the state of observability reports, I came across a stat that didn't quite surprise me, being in the observability biz for a while, but it did make me sad. ServiceNow found that 1 in 10 metrics were actually directly queried by engineers, which begs the question, are those 9 metrics valuable? What's great about that 1 metric? How do we even calculate the value of a metric? If you deleted those 9 yesterday, would that make a difference in your ability to understand your system? These are all great questions, but the best question we want to ask is, are we getting enough value from this observability data or these metrics to justify the cost of producing and storing it? Because the last thing I want you to do is indiscriminately cut out your metrics just to hit a specific short-term point-in-time billing goal without considering the value. And as someone who was once tasked with responding to a spend panic and had been told that all the low-hanging fruit had already been picked, it's quite stressful. Answering those basic questions about which metrics were valuable and in use and which weren't felt like an impossible task, especially with the tools that were available to me. So I've got a few factors that you can consider when evaluating the value of a particular metric. 1, a valuable metric is used in monitor queries to alert the on-call about issues. This does not mean that every metric that shows up in a monitor query is inherently valuable. If you've got good alert hygiene, then maybe that's the case. But really what this means is if your monitor is actively in use, does genuinely reflect an actual issue with the customer experience or an impending issue with the customer experience, if that alert has a runbook and is tuned, those types of metrics are very, very valuable and are absolutely not things that you should cut out to save money. A valuable metric is also charted on actively used and maintained dashboards. And sort of the dark side of auto instrumentation and sort of point and click, copy, paste dashboards and monitors in the open source community is it's really easy to end up overloaded with a ton of default metrics that you really didn't need. Collecting every single metric that, say, a database exists maybe isn't necessary for the operations you've got going on it. And so I qualify this with dashboards that are actively used and maintained to understand system health. A valuable metric is also directly queried by an engineer or multiple engineers, because some metrics don't get charted or put in monitors. But if people are actively querying and asking questions and using that metric to answer them, it is a sign of a valuable metric and one that you should keep around. Or if only one person's querying for it, you should go ask that person what makes that metric valuable and maybe share that with the rest of the org. And finally, a valuable metric is one referenced in a shaping rule. We talked about earlier those levers to control cost with the granularity and downsampling, with your retention window, with cardinality, dropping labels or particular metrics. And so if your organization has done the work to shape, aggregate, or filter some metric, odds are it's worth keeping, or it should not be the first one on your list to cut. It is a signal that there's some value there. But how do we roll this all up into one nice takeaway? Well, a valuable metric is one that engineers use in the course of their work to better understand the system. So if you, say, had a very expensive metric that was used in a monitor, charted on a dashboard, actively queried by your engineers, you could explain to the business that that particular metric, while being expensive and looking like a good candidate to delete, is actually mission critical for your org, and you should look elsewhere. This weighing of the cost versus the value is the conversation you need to have with leadership and above when making decisions on how to optimize your spend. And helping translate beyond financial cost and into value is what will get you the best results there. And so what I wish I had was our metrics analyzer. It just shows in one place what metrics are most valuable and least valuable, who's using the metric, how much, and by whom. However, if you don't got a vendor like this, you can totally DIY a metrics audit yourself. And I want you to ask, what metrics don't we need? What metrics aren't being used that should be? For instance, a metric may see frequent queries, but if they're from a single user, maybe that user just instrumented and hasn't shared with everybody that this data is available. For me, I know that when I installed Cube State metrics at a previous company, I was totally stoked that we could finally associate our metrics with a particular pod. I kind of ran around the org and I said, oh my God, we've got Cube State metrics. You're welcome. Such a gift. And the developers kind of looked at me with like, okay, I don't really know the value of this. I didn't explain to them example queries that they could now use to pinpoint if things were affecting a particular pod or what was going on there, specifically for cron jobs too. So you have to tell the story of how your metrics are valuable as well. But the steps to run a DIY metrics audit scope to what your team is responsible. I really, really hope your organization has team tags or team labels on your metrics so that you can just go into your metric space and filter to only the metrics that your team needs to care about. Scoping down the problem space is a good first step. The second thing you want to do is identify those easy wins that you can trim right away. Metrics that are not in a monitor, not directly queried, or not powering charts by visited dashboards. Those are things that you can ask the team, hey, do we really need this? Where did this come from? Was this just in the default out-of-the-box configuration? I think we can trim it. Aside from looking at total metrics to drop, you can also identify labels that are unnecessary. Sometimes the Prometheus instance label is not super relevant for particular metrics, and so dropping that can save you cardinality and save some spend. Or if you're running in Kubernetes and you're running all the same instance type for your nodes, you really don't need the instance type label. That's just kind of cruft you can get rid of. But the most important step of doing a metrics audit is sharing your successes, not only how much cost you saved, but telling the story of how you came to these decisions, the feedback loop that you had, and sharing those practices across the org, because this just isn't stuff that we're taught in school. And after you do your point-in-time metrics audit, you take all the easy wins, you then can start making a repeated process where you continually evaluate, maybe once a month when you're on call, or once every 6 weeks when you're on call, just reviewing your metrics configuration and making sure there are no alarming trends that will cause a spend panic. So with that, I've got a few resources that I can share out. One is how Glue uses the Open Telemetry or OTel collector to drop particular metrics or labels and really get to what they call the minimum metric set, which I love. An article about how to drop and delete metrics in Prometheus, if that's what you're using. A blog post on how recording and data roll-up rules, like I mentioned, can help your metrics. And finally, that very hilarious talk, Observability is too damn expensive, from DevOps Days London this year. Those are some resources. If you want to catch up with me, you can find me. You could email me if you want. You can find me on Hachyderm, which is Mastodon, or LinkedIn. If you're going to KubeCon, please come to my workshop, OTel 101, Let's Instrument for Traces. Or if you want to hear a fun, scary tale about how I took production down, there's a recording of There's No Place Like Production. And with that, I am ready for questions.
Thank you so much, Paige. And of course, we know that you took production down on purpose just to make it a catchy workshop. So that's a genius idea.
It was a gift of learning. I really wanted everyone to learn.
Exactly. So of course, when we do production down, when we do mistakes, we do this for you. We do this on purpose. So just to show you that, we failed on purpose. Nice. So I really enjoyed the presentation. Thank you so much. Drop some clapping in the chat. And yes, so if you have any question, just drop it whatever you want. There are different levels. Of course, you talked about Prometheus, different tools. I loved also the introduction. So maybe I have one question, like if this presentation would be like maybe available somewhere, if someone maybe, I don't know, there is something else about this.
Yeah, I will make these slides available. I've got my personal blog, PagerDuty, Paige, not Page, like the company. And I can make those slides available as a PDF and drop those further resources. I really think that if this was a space that interested you, there are a lot of blog posts that go into deep dive details that you can use as your trusted guide as you go on these efforts. And one thing I forgot to say is this is totally the type of work that builds your case for a promotion. When you can tie the work you do to an absolute business value of cost savings, that is very good fodder to make it to senior, make it to lead, and beyond.
Nice. Maybe I have one question. Like, what do you think is the most common mistake that people do, like when we do, for example, you talked about the monitoring, like setting the monitoring up. So what do you think are like the common or the most common mistakes?
I really think it's not taking a look at when you're copy pasting a dashboard or flipping on a new integration. Look at the metrics dictionary, look at everything that is emitted and think through, when would I need this? Do I really need this? And if you can proactively, as you're turning on new monitoring and metrics, proactively filter out things you don't need, you're going to be saving money along the way. I think I really love auto instrumentation, and I love the open source community for sharing the monitoring configs that they use that work for them. But it's not one size fits all. You really got to tailor things to your org and your context.
Nice. Thank you. Thank you. And my company, they call me also the icebreaker because I do these icebreaker questions. And of course, now we have a question now. So this worked. And so, do you have any recommendations for resources or ways to learn for people who would like to learn more about metrics?
Yes. So if you want a general conceptual understanding of metrics, there is a great book from Manning Publications called Software Telemetry by Jamie Riesdahl. That is a book that talks about building an overall monitoring system and the considerations you have along the way. If you're looking for tactical guides, I recommend asking or figuring out what specific metrics format you're using, whether that's Prometheus, whether that's a proprietary agent from a vendor, whether that's open telemetry metrics, because each of these systems are built a little different. Some are push, some are pull, and it will make a difference what configurations or options are available to you. So if you want tactical advice, you got to scope down your query to what metrics you're actually using.
Like a really great answer. Also, if you send me like the link of your page, you can give it like in the private chat now, or you also put this in the description. There is also the link in the description, so you can follow Paige, of course, and so on. We have people clapping, of course. I think this was a very funny, like say, presentation. I can say it's not like so easy to talk about this, but really loved it. Really loved the style. Nice, perfect. Thank you so much, Paige. So if you can stay a bit more at the end, I'll invite you again. Otherwise, thank you so much for coming.
I'll stick around.
Really appreciate it. Yes, that really make me happy, but that's more like my own thing. And yes, nice. So thank you so much, Paige. And see you later, hopefully. Thank you so much. Thank you so much for coming. So Let me remove. Well, let's see if Jessica's here. Jessica, you're there? I can see your hair. Are you there? Okay, nice. Okay, perfect. Nice. Thank
And
you.
there. Now I'm unmuted.
Perfect. You were ready. You were just hiding. You're not in the
Right,
camera.
right.
Nice. Thank you. Nice. So, Jessica, you work in developer relations at Honeycomb, right?
Yes.
Yes. So, would you like to introduce yourself? Tell us a bit more about Honeycomb, and then maybe when you want, you can also share your screen, and then we can start the second talk.
Sure.
Yes.
Let me get that screen share going, because that's always the hard part. Right.
Yep.
So my title is Engineering Manager of Developer Relations at Honeycomb, which is really fun. I work at Honeycomb because I believe observability is a crucial part of working with complex systems. And my personal mission is to help software developers develop and recognize our skills in working with complexity in the longer term hopes of maybe we can use those skills to work better in the world.
Nice. Really like this intro. And so, if you can give a trailer about your presentation, and then of course, then I'll let you start. So, yeah.
All right. So Paige talked about metrics, which are very good for monitoring, which is knowing when something might be wrong. But I believe that observability goes a lot farther than that. Observability goes into what is wrong and how do we fix it, and also how do things work when it's working well. And
Nice.
I am excited here to talk about OpenTelemetry in particular, because I think OpenTelemetry creates an industry standard for observability that makes it way more accessible to all of us.
Nice. And this is the reason why we try to have a similar topic during our events. So sometimes we have some interesting crossover, we can say. So nice. I think we can start. And yes, best of luck. Bye.
Great, thanks. Okay, can you see my screen? I'm guessing yes. All right. Software teams. I believe that software teams are made of people, but also the software on them, like the software that we create. My mission as a software developer is not to write code. It's to provide valued capabilities to the customers or the rest of the business so that they can provide value to customers. And in order for me to do that, the software has to be running in production. And that means defining a team as everyone necessary for my job to be successful. The software is on the team. But the tricky bit about that is that we can't just talk to it like we can the other people in Slack or in person. We can ask them questions. We have relationships with them. But what about the software? There's like this barrier between the social and technical halves of the socio-technical system that Doctors Wood and Cook call the line of representation, because all we have to know what's going on in our software is screens, command lines, the SQL queries we can run, the log viewers that we can look at, and the code, the IDE and the code itself. And these representations of what's happening inside, that's all we've got. And then the only control we have is the buttons and the commands that we give ourselves. So observability is super important because it's how we know what's going on inside the technical half of this system. And it's how we can know what's not just when something is failing, but what is failing. And on the performance side, what's slow? What's going on there? How can I fix it? And then also on the part where our system is already working and we don't actually know how, because trust me, you don't know exactly how your software system works. It's way past, all the interesting ones are way past what can fit in one head. So this is really useful when you're adopting some code that you haven't maintained before. It's really useful whenever you join a team or join a company. How does it work really? And observability can help us with that. As a result, we can reduce downtime, improve performance, and also get a clue about that code that we just accepted responsibility for. So I define observability as we can see what's happening inside our system because it tells us, and here's the particular power of software developers over people like biologists or chemists who have to work with the world as given. The world we work in is manipulated by us. We create the rules for how our software works, and we can make it tell us what's going on. To do that, we use telemetry. Telemetry is a particular kind of data. It's just for us as operators and developers. These words come out of rocketry, um, where, like, you know how fast a rocket is going, not because you've got a cop in an airplane with a radar gun, but because the rocket tells us. It sends telemetry back to its creators to say, I'm going 500 miles an hour in this direction or whatever. And that telemetry comes from instrumentation. Instrumentation is the name for code whose only purpose is to send telemetry back to us. So we have this already. We have, like, I don't know, a log statement is instrumentation, and the log text is telemetry. It's just not the best telemetry that we can get anymore. Because the best telemetry is traces, and I'll tell you all about that in this presentation. But first, I have to mention that there's not just one rocket. I mean, okay, with rocketry, there's usually one rocket. They're usually pretty independent of each other. But in software, that's not true, because we have various processes and components talking to each other all the time. And we need to trace not just what each one is doing, but what they're doing together. Like, it takes a lot of parts to provide value to customers. And I want that whole story of how value was provided, not just little bits of it here and there, like we get with log statements. So we need to pass some information from rocket to rocket, from service or process or component to each of the other ones that it calls into, so that we can connect the dots here, so that we can say not just what happened, but why it happened, what triggered it, trace it back to something that came in from outside. And passing that correlation data down is called propagation. Okay, so we need all of those things: propagation, instrumentation, telemetry, to get observability. They're not sufficient, but they're necessary. And from that, we can get a distributed trace. And not everyone has experienced a distributed trace. So here's my 3 minutes of getting from logs to traces. So if you've got this is a pretend really sad little e-commerce app, and we just got I don't know, a checkout request coming in. We're going to log that we received the request, of course, and we would log that we're calling the cart service, and then maybe we would log the database statement if we're lucky, and so on. But if you take those logs and add that correlation data, then you can say why each one of those happened. Not just a single request ID. That's not enough. You also have to give each line its own ID and then correlate between those, so that you can say receiving the post caused calling cart, which caused this database query or whatever it is. And then, of course, you record which component or which service each of those took place in. And then you also record when they started and when they finished. Now, this means that you're holding state. You're holding state in each of these places, so that you can say in one event when it started and when it finished. And that gives you a duration, which is going to be amazing for finding performance tweaks. You can also say when they errored and make that really clear. And then you can add any other attributes. So Paige talked a bunch about cardinality. Cardinality on metrics, expensive. Cardinality on events, dirt cheap. You can add all this information because it's just one field. There's no multiplication happening. So everything that you would log in separate log statements, you wind up putting in the same event. And then you give it all a trace ID, and it ties it all together. And this makes it a story. So a trace contains many spans. Each row in here is an event, which is also a span. That's a technical term. And the trace ties them all together in this little causal structure, and you get the whole story of we call it a customer experience. Okay, it's one web request coming in. It's not like the whole customer experience, but it's one where we're providing a piece of value to someone. And we get the whole story, and that's really pretty great. So we can tell the story of a request, which explains to us how our system works, because you can see how all those different services fit together. When something fails, you can see exactly where it is. So it doesn't become a case of my logs versus your logs on two different teams of what the cause of the error is. It's right there. And everyone on all the teams is looking at the same trace. Super valuable. And then you can totally see what's so slow because you've got the durations right there. And then you can know what to do. Now, if you want to look at a distributed trace for real, we can do this. We can go to justitron.com/hotel. And this is the OpenTelemetry demo app. It is a fake e-commerce site. And just so it's going to redirect you to an HTTP. Someday I'll get DNS working in this EKS cluster. It's fine. You can click on some stuff. You can add it to your cart. And then you can place order with this fake, very nice fake data. And it will not, in fact, send you a confirmation email because it is fake. But what you can do is go over to justitron.com/hotel/Jaeger, or you same Kubernetes URL, but /Jaeger. Jaeger is an open source tracing tool. So it receives and displays traces. And okay, I can just click find traces. I'm on the front end web. Ooh, this big slow one. It's big because there's a lot of spans in it, and it's high because it's slow. Yeah, there's our checkout request. And you can see the client side and the back end, and it looks like we've got some clock skews so that they don't fit inside each other. This is fine. I'll let you dig into that. You can look at any of these spans. You can click into the tags and see some details, some attributes. So you can play around with that on your own and explore distributed traces right there. That stuff is open. No guarantee that it'll work 5 minutes from now, but it's working right now. Good job. Good job, demo. Okay, so there's a shopping cart and a trace that you can go look at. And inside each of those spans, there's a bunch of tags. Some of these tags are generic, like URL, and some of them are specific, like order amount. That's specific to this particular span. Okay. I'm going to back up and talk about how this happens, how it gets there, because to understand tracing, it was like questionable to me as an engineer until I understood like the implementation of it. So we have some instrumentation in the code. This emits telemetry, and the result somehow is observability, is me being able to understand what's going on inside the software. But the data, that telemetry, it does not go directly into my head, as it is not that easy. So what we need is what's called a telemetry backend. I don't know why they call it this, because it's also a front end. So that's really confusing. From my perspective, this is the front end. But from the perspective of the software, the telemetry backend is a database that all this telemetry goes into, and then the front end that can query the database and show it to me, and that's where the value comes from, the observability. All right, so there's you have various choices of telemetry backend, and all of your telemetry is going to wind up in there. The beauty, and there's going to be some sort of pipeline, you're going to have some stuff in between, it'll be fine. Oh, and then you need the propagation of the trace ID and the span ID between your services. That's another thing that's necessary. The beauty of OpenTelemetry is that we're going to get the protocols. You need a consistent protocol for the telemetry. The pipeline and this propagation is all going to be open source and standard across the industry. And then what backend you choose, whether you run Jaeger or whether you pay an observability provider, that you can decide later, because all of this stuff is in OpenTelemetry, and everything that you inject into your code and everything that you run in your network is open source. And not just open source, but like really well curated open source, because OpenTelemetry is the second biggest project in the Cloud Native Compute Foundation. The biggest one is Kubernetes. So this is a serious governance organization, and it's got all the bureaucracy and all the care and all the like ongoing reliability. This is a real foundation. and also a diversity of influence from across the industry. So OpenTelemetry gives you a protocol. It's called OTLP, which stands for Open Telemetry Protocol. Really, the L is silent. There's a collector. I'm not going to talk about that today, but it's a component that does the magic you need in the pipeline, including converting from old formats like Prometheus or OpenCensus or OpenTracing. And then you still need that propagation. The trace parent header is actually a W3C standard, so that's an even higher level industry standard for HTTP. OpenTelemetry also has like standards and conventions for gRPC and Kafka and a bunch of other message passing protocols. Oops. Right, so you get all this. What do we have here? OpenTelemetry does this by recognizing not just your language, but also your web frameworks. And so it can provide libraries that plug into existing HTTP client and server and also gRPC and also Kafka and blah, blah, blah. Libraries per language and inject the trace ID and span ID and pull the trace ID and span ID out at the other end and continue the trace so that you get this really complicated. It's invasive even. It has to be like at a low level in all your HTTP requests and receives and your other network sends. But OpenTelemetry provides this with instrumentation libraries, and there's a lot of them. Also, that these create automatic instrumentation. Also, there's an SDK for you to create your own spans and add attributes to the existing spans and all that stuff per language. And even like database clients have instrumentation libraries so that you can get things like what SQL statements are taking so long and how many of them are you running. So OpenTelemetry provides the libraries that we need to instrument almost everything. There's a lot. And that gives us the scaffolding, the outline of the trace, and also a lot of generic fields like HTTP URL and client IP. It's not going to put the headers on there or the body of the request because that might be sensitive data. So you need to do that yourself for what's important to your app. And you can add things like order amount, order ID, user ID. Cardinality does not matter because these are events and all of that is free. And then if you can derive your metrics from this, poof, you get all the metrics at once. Right. You may ask what automatic instrumentation is available for my language, and I recommend you go to that opentelemetry.io/registry to find out. That's the useful stuff. There's also documentation on all the major ones. So overall, I highly recommend using auto instrumentation. Here's an example of some code in Node that does that. Just sets up the SDK, configures it for where to send. Some of that's in environment variables, and it adds the automatic instrumentation for HTTP and the file system in this case. Now, this code on the screen does a little tweaking from the defaults for bad reasons that will become clear. And do add your own attributes to spans. This is like number 2. Step 1, use auto instrumentation. Step 2, add the attributes that matter to you. So this code is calling getActiveSpan and setting attributes for image height and image width because that's relevant here. And this is a trace for the particular program that I'm showing here, and it's reading some images, and those read PNG files have the attributes, which I have failed to show on this slide. Dang it. And then, come on. All right. So do that, and do look at heat maps to see what is slow so I can derive metrics from these events in Honeycomb. And a heat map is a fun graph. Not everybody knows what it is. I only learned it a few years ago. But in a heat map, higher is slower in this case because it's a heat map of duration, and darker is more. Like at the bottom row, you can kind of see that there were more things happening. This is a fairly sparse heat map. You see that some things are slow and more things are fast. Now, this program does something interesting with the heat map. Oh, here's a better heat map that shows more things, and you can kind of see how often things are slow. It gives you like the whole distribution of duration instead of only the P90 or only the P50 or whatever it is you choose to aggregate. I love heat maps. Don't do what I did and create 7,000 spans gratuitously in order to draw a heat map. But I think we have 5 minutes. I think I can actually run this program for you. This is my silly one. And if I run it with the input of the special daily dev configuration, it's gonna send some spans. I think it sends 7,000 of them. And then let's see, let me open that in Chrome. And then it's going to run a heat map. Ta-da! We get the daily dev logo. That is me playing with OpenTelemetry. And if you click in here, you can see a whole trace. Eventually, it's a very large trace. It's 7,000 spans. But look, it has some. Oh, I did this for Christmas first. It has some Christmas ornaments in it. And that is the end. Whoops, this button. Happy holidays. You can, oh, this is the video. Skip. There, that's what I want. Wow, come on. There it is. There's the QR code and the link for references and for the instructions for how to create your own picture in a Honeycomb heat map with a free account, should you desire to show off your observability mad skills. The end.
Yes, yeah. I loved the surprise, like even in the presentation. I think those are the best presentations when you can adapt and make some. This was not expected, so thank you so much. I took a screenshot, but I'll take another one later. But yes, so yes, you really went the extra mile. So really loved that. And of course, so first of all, drop some claps in the comments. And yeah, it was great. And I have one question, because at some point you talked about different languages. So there was like JavaScript and not SDK,
Right.
but I didn't understand. Like, maybe can you elaborate a bit more on that part? Maybe it was like the integration with any language. What was that?
Yes. Thank you for asking. I really whizzed through that bit. OpenTelemetry has libraries for most programming languages, almost all of them, that are written in that language, and they will emit the standard OTLP formats, as well as other ones with some plugins. And the SDKs they're really strong in Java and .NET and Node, and they exist for Ruby, and there's lots of others. At opentelemetry.io/docs, you can go to the getting started, I think, and then there's instructions on about a dozen languages. But the OpenTelemetry, it has to be open source, because like in Honeycomb, we used to have custom instrumentation libraries, and we had a great one for Rails, and then we had like 5 or 6 others. But as one company, we can't create instrumentation for every language. There's a Datadog agent for, well, I guess the agent mostly runs, but there's New Relic libraries for a bunch of different languages. But it's so much better to have one open source project creating standard instrumentation that all the different observability providers can accept and do accept, that we have the whole community working together to emit standard telemetry from all the different programming languages. And the OpenTelemetry provides an API, so there's like a specification for all the different things that it should be able to do. So that's consistent from language to language, how you do things, but yet each SDK is customized to the conventions of the language. So in .NET, it uses system.activity. because Microsoft already has a thing for this. And in Java, you can use, in Spring, you can use annotations. So yeah, so there's per language implementations that all emit compatible data.
Love it. And I think if I got it right, so this is basically good when you have, of course, an application that is not a single application written in one language, but it, sometimes usually 90% of the cases applications are done in different parts, microservices. Maybe there is a authentication in Python, something in JavaScript. So you need I would say consistency among all, not just a single app, but all the apps.
Observability is very much a cross-cutting concern. Now, if all you have is a bunch of Java services running in Kubernetes, you can do this in like one step with a Kubernetes operator, also created by OpenTelemetry, and just inject all the instrumentation at once. But also every other language has, at worst, a little bit of initialization code and a library to participate in the trace.
Yes. So I get what you say, that but usually the applications they are never that simple. That it's only one stack deployed every. I never experienced
if you
one
have
single.
a trivial stack, then it's trivial to add instrumentation. But when you have a complicated stack, then it's not too bad.
Yeah, absolutely. So yes, so thank you so much, Jessica. Maybe I have even one more question. Like, what do you think is, like, I don't know, the next step? Maybe because you made like this presentation. So maybe what do you think might be, like, I don't know, the next step if someone got you interested? Yeah.
I mean, I'll put my link in the chat for more references, but go to opentelemetry.io and go to the docs and try the getting started for your favorite language. Oh, and sign up for a free Honeycomb account to look at your traces, because that's way easier than running Jaeger.
Nice. So I already shared this in the chat even before you said it. So I did my job. So now you have just one click away. So this is for the lazy people who don't want to type opentelemetry.io. So you can just have to click. You have no excuses now. And that's it. So Jessica, thank you so much for your presentation. And if you can say, I'll invite you back at the end. Otherwise, thank you so much for your presentation. Okay, nice, perfect. Okay, okay, nice, Leon. Last, and I hope not least. So Leon, of course, because we have talked for a while, we're already friends. I don't know, after 2 minutes, and so Leon, really, I love your energy. So thank you so much, also because we are at the end of this, also kind of long day for me. So yeah, Leon. So you are now you are a principal technical evangelist at Kentik, right?
Yes, I am.
Perfect. So I like the title of your talk, but I'll let you say the title because you think you deserve that, and then we can get started. Of course, feel free to introduce yourself, and then we can start.
Sure. Actually, the introductions and everything are in the talk, but I really, coming after Jessica and Paige, I don't know how much I'll be able to add. I'm going to try. I'm going to give it a good college try, but they really have set the stage, for me. Just I could come on and do anything at this point because they're amazing, and they've done an incredible job.
It's like singing after Whitney Houston. I don't know. You gotta try.
Well, there's that too, right? Yeah, no pressure. Exactly.
Nice. So I really love that. So can I share your screen?
Yes. Yeah.
Perfect. Nice. So give me a trailer of this presentation, and then I'll let you start.
Sure.
And I'll leave you alone. Yeah.
So Paige started off by talking about the value of metrics and telemetry, and then Jessica kept that whole concept going with the value of both standardization and open source, and having that, being able to deal with a multi framework platform and all of that. And what a lot of that work frequently rolls into is what I affectionately call the poke in the shoulder, the alert, the thing that wakes you up at 2 o'clock in the morning that everyone hates. And so this talk is really focused on how to make those alerts not horrible for everyone involved, both the people who have to build them and the people who have to receive them.
Yes, so I'll let your talk to start. I just want to say that I've worked in the past for the European Space Agency, for the Copernicus project, Earth observation. So we had this big system with satellites, and for us, alerts that were crucial, because when you have to deal with this sort of big project, sometimes things don't go right, and we had like I don't know, SMS alert of any types. So I think I'm really looking forward for this one. I think this is a crucial part for a successful application. So Leon, I am already sold. I hope you also are in the chat. Feel free to drop your questions, because I'll just stay in the back because I want to really, really listen carefully to this presentation. I hope the slides are okay. I just see an orange screen now, but
Yeah,
I hope
yeah.
that's okay. Okay, perfect.
It's
Best
all
of
good.
luck. Bye.
Bye. Okay, so a few years ago, I was tweaking a new alert that I was building, and I accidentally cut 772 tickets twice in 15 minutes. And the worst part was I didn't even know I had cut those alerts until the help desk staff came up to my cubicle and invited me to their area to manually close all 1,544 of the tickets that I generated. And with the benefit of time, experience, maybe some therapy, some alcohol, I can reflect on this formative event. I mean, whose fault was it? Certainly there's enough blame to go around, right? I mean, part of it was on the operator. That was me. Part of it was on the tool. Like, why did it let me do that in the first place? But in a larger sense, it was an immature philosophy about what alerts are and what they're supposed to do. So I want to thank you for coming to my talk. Alerts don't suck. Your alerts suck. My name is Leon Adato. I'm a middle-aged white dude giving a conference talk. You really don't need to know anything else on this slide. I will tell you, I will share the slides later and you can read all the stuff that's on there. What's more important is that you understand this is an oyster talk. Now, what I mean by that is I have 20 minutes. I cannot teach anything in 20 minutes. In that amount of time, about the only thing I can do is irritate you. Now, when an oyster becomes irritated, it does one of two things. It creates a beautiful pearl, or it dies. It is my hope that in the next 20 minutes, I do not irritate you to death. However, I do believe that you should be forewarned. Instead, I want to give you just the grain of an idea that you can layer over with your own experience and ideas until it is polished and unique and valuable to you. So the SRE handbook, I have it right here. The SRE handbook defines an alert. It says, and I will read, it is a notification intended to be read by a human and that is pushed to a system such as a bug or ticket queue, an email alias or pager. I don't want to blaspheme the Holy Scripture, but what the FSCK am I supposed to do with that? I mean, how does that make me feel that alerts are anything except useless and pointless? And the reason is the SRE handbook has failed to explain what the value of an alert is. And ultimately, that's what this talk is about, how to make alerts valuable. Now, if you don't remember anything else from this talk, I'm going to put the two most important things right up front. The first one is that, like opinions, email rules are like assholes. Everyone has one and they all stink. What I mean by that is that if you have an email rule that handles the incoming alert messages, you have already admitted defeat. You have absolutely no intention of dealing with that alert right now. And for an alert, the only time frame that is valid is right now. That's the first point. The second point, this is the beautiful hill that I am willing to die on, and it's called FYI alerts are trash. I don't understand when people say that, oh, this is just an FYI alert. I don't do anything when the first message comes in. I only do something when I see 4 or 5 messages come in over 15 minutes. You know what? I don't get paid by the kilo for this stuff, okay? How about I give you one alert when the thing has happened 4 or 5 times in 15 minutes? So again, FYI alerts, no use for them whatsoever. Don't have them. Now, the point of this talk is that alerts need to have value, and I'm going to share why and how over the next 5 lessons. And the first lesson is on the fundamental nature of what alerts are. And I have to tell you the 3 important rules. The first one is that alerts are not the same thing as monitoring. They are fundamentally different. Also, alerts are not monitoring. And finally, for God's sake, alerts are not the same thing as monitoring. Monitoring, as Paige and Jessica have told you, is nothing more and nothing less than the regular ongoing collection of data, metrics, events, logs, and traces from a set of systems. Everything else, alerts, dashboards, reports, are a happy byproduct of doing the first thing, of doing the monitoring. By all means, collect all the data you want, with the exception of Paige's talk about, making sure that they have value. But monitor the crap out of things if you want to. But alerts should be based on action. For example, every month, your boss catches the monthly dev talk and probably wanders into your cube with a pair of socks that they won in a raffle and a shiny new monitoring tool. And the first thing you do is you unwrap that sucker, the monitoring tool, not the socks, and you create a high CPU alert. I have a secret for you. CPU alerts are bullshit. High CPU isn't a problem. It never was a problem. If I have an application that is running at 98% consistently, but it's processing all the jobs and everything is getting done, you know what I call that? Correctly sized. It's doing what it's supposed to do. Now, at this point, some of you are probably thinking, oh, he's going to oversimplify everything down to CPU, RAM, disk, and bandwidth, and ignore the lived reality of everyone on this talk, who are dealing with a metric ass ton of metrics, events, logs, and traces on a daily basis, because what Leon is talking about is boring, old, traditional monitoring, not the fancy observability stuff that we do. And that's my second lesson. I see it happen a lot. Conversations about alerts get stuck on the point of monitoring versus observability, when in fact it's monitoring and observability. It's an inherently false argument. So let's flesh out some important nuances. Now, I'm about to draw a line on the slide. There it is. And I do so with absolute respect and gratitude to everyone who fought in the trenches of the observability flame wars of the last few years on Twitter and LinkedIn and everywhere else. And so I need to say that what I'm about to do is lay out some differences or nuances between monitoring and observability for the purpose of alerting only. Also, if you are trying to fill out your observability bingo card, you're welcome. Here we go. So first of all, we'll start off with monitoring. Monitoring has to deal with the known unknowns. We know something can break, we just don't know when. It also deals with all cardinalities, anything from high to low to regular. If something happens a lot, monitoring typically wants to know about it. Observability, we'll talk about in a minute. Also, mostly manual correlation, because again, simplistic triggers are not usually the ones that matter. But if you know that it's when there's high CPU and also there's this many users on the system and that this many sales are dropping, then it's a problem. That kind of correlation is going to happen manually in most monitoring focused systems. And finally, they're domain specific signals. What I mean by that is that when something is wrong with a storage system, those elements are fundamentally different than when something is wrong in an application that's getting most of its telemetry through tracing. All right, so that's monitoring. On the other side of the line, you've got observability. So as we've heard about from both Paige and Jessica, it's the unknown unknowns, right? We don't know what might break and we don't know when it could break. And more importantly, high cardinality events are the ones that observability systems tend to focus on, the ones that we could never kind of grok on our own. And correlation is baked in because of that, because it's dealing with a huge amount of data and it's more than any one human brain can reason about. And finally, it tends to focus on golden signals, signals that are true irrespective of the domain or platform. And those golden signals are usually latency, traffic, errors, and saturation. Whatever that means for your system, those are the golden system, or tend to be the golden signals. Again, for the purposes of alerting only. I really hope that Jessica doesn't rat me out to charity majors and she comes to my house and eviscerates me on the front step. Okay, more to the point. High cardinality events are derived from a large set of disparate data types that are coming from all sorts of places. There's really only one way to make that work, and that's to let the computers do the work for you. Now, marketing folks will tell you that that's AI. Of course, most of us on this in this call know that AI is just a bullshit marketing term for 3 if statements in a trench coat. Now, that aside, you can see how it's challenging to talk about alerts in this context. So I'm not saying that my thoughts on alerts don't apply to systems that are focused on observability or built to provide observability level information. They do. It's just challenging to give detailed examples in 20 minutes without keeping you all here past lunch or happy hour or whatever time of day it is for you. Okay, back on track. Alerts have to matter. To you, of course, because you're probably the one building them, but more importantly, to who's ever getting them. I mean, what do I mean when I say an alert matters? Well, actually, I have a pretty simple algorithm. The point of an alert, okay, is that if and only if it is to get a person to do something right now about a real problem that is happening right now. If all of those things are not true, it's not an alert. It might be something else, but it's not an alert. And of course, the next thing you're very likely thinking is, well, okay, what are those other things? Okay, let's talk about that for a minute. If what you have is something that doesn't involve a human, it's happening right now, you want something to happen, but it's, but it doesn't need a human involvement, it's automation, right? We'll talk more about that in a minute. If it's not going to need to be dealt with right now, it's probably a report, something you can read at your own leisure. If it's not a problem, but it is things that people need to know about, it's probably a dashboard. And finally, if you have no intention of doing something about it, delete it. To Paige's point, if you're collecting metrics for no reason, you are using up resources, money, time, effort that could be better spent elsewhere. Which takes us back to the high CPU. There are 4 common pitfalls when it comes to making alerts matter. And the first is the trigger condition itself. So as I said, high CPU isn't a problem. Now, if the CPU is high and there are more jobs in the processor queue than there are CPUs or cores to deal with it, and the situation is extending longer than, let's say, 5 minutes, and I can see the application is degrading, that might be a problem. But what I just defined is something that is incredibly different than, oh, the CPU is high, right? So again, the trigger in non-sophisticated triggers that are overly simplistic, are one of the pitfalls. Now, sometimes the issue isn't the trigger, but the time frame. Everyone looks at this graph and they think they know exactly what to alert on, right? They see that and they say, oh, well, there's the problem, except that might be completely normal. That could be month-end processing from your accounting team, or it could be elastic compute that realized that you're not doing much, so we're going to ratchet down and turn off a few systems, and so relatively everything spiked up. What nobody notices is that it's the same rise, except it's over a larger amount of time. And this is what our human brains aren't conditioned or trained to see. This is what monitoring and observability are for. And this is probably what we should be alerting about. Not just this rise by itself, of course, in conjunction with other critical pieces. And it comes when we conclude time as a fundamental aspect of our triggers, which I see people not do. Now, another pitfall is using fixed thresholds. There is no one threshold fits all. There's not even one threshold fits most, okay? Every system, and I don't mean a server or a router or whatever. I mean, any application, any multi-connected, microservices-based, any of that has its own unique behavior profile. And so better is to use baselines. First, collecting your monitoring data, understanding what normal looks like, and then setting your threshold to be whatever it is, 10% over normal or whatever it is. But of course, that leads you into other problems. For example, if I have a 1 gig disk that's hovering at 70%, that's 700 meg, 10% of that takes me to 770 meg, which isn't like a get out of bed urgency, but if the spike continues and continues quickly, I may not have time to respond. So setting a threshold of, a percentage over baseline with a fixed limit means that, first of all, I won't get alerted for those real short ones because they'll never alert. And I honestly don't care that it's 10% over normal because it's still got plenty of disk space left. But I can also see where something hits within that yellow and red line. Another trap is having a lack of automation. And again, I know that disk space is overly simplistic, but just for the purpose of time and to be able to create a clear example. When you have a disk full alert, 90% of the time, you're going to do one thing, and everyone knows what it is. You're going to clear the temp files. That's what you're going to do. And if it fixes the problem, you're done. And if it doesn't fix the problem, okay, you go back to it. But if that's the case, why not have the computer do it for you? And just as proof of the fact that this works, I was at one company, I implemented exactly this. If disk is full, just clear the temp directory, and if the problem goes away, fine. What I ended up doing was reducing 3,000 help desk tickets a month, which calculated out to $8,000 of staff time responding to alerts that didn't matter, or which they had already built their scripts for, which I just ended up using in the automation. I didn't write it myself. Okay, so there really is fiscal results. So one of the most powerful aspects of alerts is that they are witness to the exact moment when a problem happens. Nothing can be more effective than having the right response at exactly the time when the problem is occurring. Now, some folks will skip over automation because they think it's hard, but the truth is that figuring out what automation should do is easy. All you have to do is find the person who's getting that alert in the first place and ask them this question. When this thing happens, what do you do about it? And if they say, I type the gfrinkle command and it clears right up. Gfrinkle is not a command. For those of you who are wondering, do not type the gfrinkle command. It doesn't do anything. Okay. Anyway, they say, I do this. Well, how about this? How about I create a script that does the command? And if it doesn't fix the problem, then I will let you know. So imagine this sort of cascade or this routine, right? Again, simple example, I've got an IIS server and the application is slow. If anyone has ever administered an IIS server, you know that whenever anything happens, the first thing you do is you clear the application pool. It's just what you do. Now, if that happened automatically, and then you waited, and at 2 minutes later or 5 minutes later, the problem continued, it persisted, okay, fine, now you reset the IIS service. Not the whole server, but the IIS service, okay? And then you wait another 2 minutes, 5 minutes, whatever it is. And then if that doesn't work, you rebuild from image, or you restart the VM or whatever platform you're on, and you wait. And then you move, you vMotion, or you move to a new region, or you move to a new whatever it is that you do, and you wait. And then if the problem is persisting, you send a ticket. Now, the best part about this is not only that it probably will catch the problem in that cascade or whichever cascade you do, but also you have the ability to inform your ticket, your ultimate ticket, with all the results of those automatic responses, so that when you do wake somebody up at 2 o'clock in the morning, A, they know that all these evasive maneuvers have already been done, and B, they have the results right there, and they can use their big human brain for what your big human brain is meant to do. And that takes me to the most important lesson of all, talking to people nicely, because nobody at your company is a psychopathic homicidal clown. Probably. But with the same determination of the world's greatest detective on the trail of the real killer of my app 123. The only way to understand how critical an application is, and the only way to understand how much someone cares about its performance, is to talk to them and get context, which means you need to hunt down the right person. And I say hunt because the person who asks for an alert initially is not the person you want to talk to. The requester is going to lie to you because you are a checkbox that they have to get past to get their application rolled into production. And they are going to tell you, no, this thing is no weird errors. It's made of, it's coated like a steel rock. It's made of angel farts and unicorn spit. It's never going down. And that is, of course, a lie. So you need to find the person who is receiving the alerts ultimately and talk with them. Find out what their lived experiences are. Now, these are the questions when I find that person to help me zero in on what really matters. First of all, how do you know when something goes wrong? Not when the users call, but when you look at the system, you say, oh yeah, that's the problem. How do you know? Okay, because that actually is your alert trigger. That's what you're going to actually be collecting as terms of metrics and data, and that's what you're going to be triggering on. How do you know when it's all better? This is something that a lot of people miss. A lot of times, but not always, better is when the problem isn't happening anymore. But there are some times when the problem happens up here, but the reset is down here. Again, simplistic example, disk space. Yes, of course, when disk space is over 90%, we know that's a problem. But when disk space is at 89, is that all better? Hell no. At that point, you need to make sure that you have enough breathing room. So of course you want to say, well, better is when it's at 70% for more than 30 minutes or what have you. But what does better look like? Is there a knowledge article for it yet? Because if there isn't, there needs to be. I refuse to roll alerts out into production unless there's a knowledge article that says what to do, because the recipient isn't always on call and isn't always going to get woken up and isn't always going to be at the company. And finally, can you make it happen on purpose? If they can't, you really have no idea whether the alert is alerting on the thing that needs to be alerted on. Yeah, I know. Anyway, you have to make sure that the thing that they said is a trigger is a real trigger. Now, of course, there's a certain class of alerts that you never want to make happen, like if you have an alert that tells you the data center is on fire, but we'll ignore those for the moment. So let's sum up. You have identified and interviewed the recipient of the alert to find out what's important. You've designed an alert that matters because it has real-world trigger elements. It takes duration and baseline into account. It includes automation, and it has verified that the alert is built with the intent of immediate action by a human. Great. What's next? The next lesson is actually the shortest one of all. You're not done. What I mean by this is that alerts are not set it and forget it. You need to plan to go back regularly to those recipients and find out how it's going. Is this alert doing what you want? Have circumstances changes? What have we learned about the system now that it's been running for a longer time in production? Do we need to adjust or create even more alerts? And far from being punished for your good deed by creating more alerts after doing one good, this is evidence of your success, because ultimately, the alert is doing its job. It is removing unnecessary interruptions and toil from your workflow. Now, if at this moment you are feeling irritated, I did warn you at the beginning that could happen, and it's time for you to start mulling over that grain of an idea and creating a pearl of your very own. Meanwhile, I am ready for your questions. Thank you very much.
Thank you so much, Leon. It was great. Also, the way you said it, like your energy was really amazing. I feel a bit irritated, so I hope it. I think it worked.
I have that effect on people.
Nice. So first of all, let me share something. So feel free to drop your questions. I also loved the daily dev cameo. And yes, I'll check it again later, because I was not at the PC. I saw this like while walking, because I have to walk every 30 minutes. So I saw this like it was a very short cameo, so I have to watch the whole thing again. Thank you. So maybe I have one question for you, which is like, let's say that I have my alerts like really in a bad situation. Let's say they don't work as intended. I think even worse is like they work sometimes and sometimes they don't. I think that's the worst. Like I don't even know, like if nothing is working, it's still better than working once in a while.
Right. So inconsistent is always the worst problem in IT, whether it's hardware or software. Yeah.
Yes, exactly. So let's say that I have inconsistent alerts. Where do you think that I will start work on? Just maybe the first step to get things fixed.
It really, I mean, I'm assuming that you are the person who is building the alerts, and maybe you are the person who's receiving alerts, but maybe not. And where you need to start is sitting down with the person who's receiving the alert and making sure that you are, first of all, that you are collecting all the metrics that are involved, that you are triggering, that your trigger is reasonable and also reflects reality. If it's inconsistent, it means either you have a trigger that's overly complex because you're looking for this and this and this and this, and it's not always happening, but missing this piece, which whatever this is, still means that there's something wrong, in which case maybe you need to remove that piece or create a variation on the alert, not my favorite, or create multiple different kinds of messages, or think of your alert logic as an and, as an or, not an and. So if this is happening and this or this, are happening. And also, so you might need a little bit more logic complexity, or you may need to review what it is that you're alerting on. And again, that all comes from interviewing the person who's receiving it to find out more about what it is that they really want to go wrong. It also goes back to what I said at the end, or near the end, about can you make it happen on purpose? If you can't make an error happen on purpose, then you don't really know enough about that error. And so, I mean, this gets back into unit tests and integration tests and things like that. I know a lot of us as developers think of integration tests and unit tests as, can I make it go right? But we also have to think about, I actually want to run a unit test that makes it go wrong. I want to see it bomb out because maybe it didn't go wrong the way I thought. Maybe it is accepting the word banana in that numeric field or whatever, and I wasn't expecting that. So you sometimes have to have negative testing to make sure that your failures go the way you thought.
Yeah, so if you have to fail, at least make it sure that you fail it right.
In test. In test, everyone said like fail fast, and I'm always like, how when you get like fortune cookies and you say like, my kids say in the bathroom, other people say between the sheets or whatever. I always say like fail fast in test, not in production.
Right. Yeah, that's more like entrepreneur tips. Let's say we're talking about the software itself now, of course. Nice. Yeah. Yes, I like that. So basically, so we can basically rehearse this as like, be careful with the flow. Let's say of basically a sort of error handling at alert level, because this is basically what they are. It's like error handling for humans. We can say for humans or systems.
It's important to recognize that no matter which monitoring and observability tool you use, that the alerts are queries. That's what they are. You have a set of data, and your alert trigger is really querying that data set to find a matching set of records. And so if you think of it like that, then yeah, you have to tune your query. You have to make sure that it's returning the data that you expected, just like any other set of, record returns that you're, from a data set that you would expect. And so if you think about it like that, sometimes it's easier to recognize why it's not working or why it is.
Nice. Thank you so much, Leon. I think that it's time to start to wrap up the whole event. So I'm gonna get back Paige and Jessica. So let me remove this. Ready? 3, 2, 1. Let's go. And so I'm always happy when all the speakers stay until the end. So you made my day. Thank you so much. I know that sometimes people are busy, of course.
I wasn't going to because I have another presentation to do in half an hour. But Leon, you were just so engaging and irritating.
There we go.
Yeah.
You got jokes. I love it.
That means so much coming from both of you. That is enormous.
Also me. So it's 3.
Yeah.
It's 3. So
yes,
it's not a coincidence.
Yes. Right.
Nice.
2 is a coincidence. 3 is a pattern. Okay. All right.
Nice.
Leon, I have a question.
Yeah.
Go.
There's been a lot of studies that show engineering leaders are kind of out of touch with the current experience of on-call and alert fatigue. What is your advice that folks can pass along to their managers? Or what words of advice do you have for engineering leaders to explain why they should invest in this alert work?
So there's 2 pieces about investing. I'm a big believer that IT people have to learn to speak the language of business, because business leaders are never going to learn tech, and shouting more tech at them is never going to work. It's like, Francesco can tell me, if I'm standing on a corner in Italy and I'm screaming in English, most people are not going to help me. Like I am speaking the wrong language. So you need to learn the language of business. So one of the things I tell people to do is figure out the dollar value of the alert. Go back to the recipient and say, how long would it take for you to find out this problem if it weren't for this alert? What's the impact? It would take me another 3 hours to fix the problem, whatever. Find a dollar value and then keep track of how many times this alert triggered, and go back to your business manager and said, I just saved you X number of dollars. All right. Yeah. So that's one way to get their attention. And here's the thing, even if you're wrong, you will eventually be right. If people are not, what I mean by that is if no one wants to give you the right number, just make up a number and say, well, I just saved $1 million. That's not possible. Okay, tell me what it is. You know, so you're going to get to some number and say, this alert is saving us $8,000 per month in staff time and whatever. So I'd like 10% of that back in my budget. How about that?
Ooh.
And then they say, well, it's not real money, so I can't really give it. Oh, good. So I'll just turn off this alert then. No. So,
I love this.
Finding out, I am a professional asshole. I can do this like for money.
Irritant.
Irritant. Yes.
Professional oyster.
Gadfly. So that's the first thing. The other thing, if you have a manager who needs to understand the lived experience, and this goes for creating a new alert, is do not send things to ticket queues immediately. Send it to a log file, send it to a different system that isn't an interruption, but then put the manager on that distribution list to say, this is the volume of work we're generating. Are you okay with that? and the answer might be yes, and the answer might be, oh, hell no. And that's the other thing.
Oh, golden advice. Oh, thank you. If I was still on call, I'd be using that.
The fun part is that we are dropping these tips at the end, so it's like it's like the end of an Avenger movie. So you are here at the end. So if you're in the chat, just drop whatever you use in your mind now. And thank you so much, Yes, for sharing all these great tips. And I'm happy that we made like this event, like with like 3 amazing speakers. The talks are connected to each other. We have the links to the speakers below. I really loved this one. So and I can say that it's not easy, let's say, to talk about monitoring and performance. I don't know, if you talk about the basics of JavaScript, probably people say, oh yes, I love it. But this is like sort of like intermediate, so it's more technical. Really loved it from my point of view. Really appreciate all the 3 presentations. I loved the memes, the jokes. You really made my day. It was a long day, but yeah, thank you. Thank you so much. And yes, so we are already 2 minutes over, so I don't want to steal too much of your time. I just wanted to, if you have to go, yeah, feel free. If I just wanted to show for really 2 seconds, just the daily dev page. So these events, the 30-40 events, they are brought to you for free by daily dev. As you can see here, you can go on daily.dev. Yes, we the name of our company is the URL, so it's like for really lazy people, so it's easy to remember. You can check it out. It's 100% free. So this product is you can try it for free. This event is for free. We're trying to give as much as possible to the developers community. I hope you enjoyed it. You can check it out. We have this squads feature, which is basically community for developers. We probably have soon also a squad, a group for monitoring and performance. Of course, we have to. And that's it. So thank you so much again to all the speakers. We are done. 2 more to go in 2023. I can't believe it. But thank you. Thank you so much. And of course, best of luck to everyone. Really. And yes. Bye-bye, everyone. Bye-bye. Bye-bye.